What if the first proof of life beyond Earth has already been discovered, but we just can't study it yet? Right now, on the surface of Mars, small sealed tubes of rock and soil are sitting in place, waiting. These samples were carefully collected by NASA's Perseverance rover in Jezero Crater, a region scientists believe once contained liquid water. Inside those tubes could be chemical signatures or even microscopic evidence of ancient life. But there's one major problem. They're stuck on Mars. Without bringing these samples back to Earth, we may never fully understand what they contain. Rovers like Perseverance are incredibly advanced, but they are still limited by size, power, and the complexity of the instruments they can carry. Rovers like Perseverance are incredibly advanced, but they are still limited by size, power, and the complexity of the instruments they can carry. The most powerful tool we have, the ones capable of detecting microscopic fossils, analyzing complex organic chemistry, and confirming biological activity, exist only here on Earth in highly controlled laboratories. Right now, scientists are working with incomplete data, and that limits our ability to answer one of humanity's biggest questions. Are we alone in the universe? There is also a growing global concern. If the United States reduces support for this mission, it risks falling behind in space exploration. Other countries, including China, are actively developing their own Mars sample return missions. Leadership in space is not just about exploration, it is tied to scientific innovation, technical advancement, and global influence. At the same time, the Mars sample return mission is facing serious challenges, including rising costs, delays, and uncertainty in government funding. If these challenges are not addressed, the mission could be postponed or even canceled. The solution is clear. Federal policymakers must continue to increase funding for the Mars sample return mission. This mission is already in progress. NASA, working with European Space Agency, has developed a plan to retrieve these samples and safely return them to Earth in the 2030s. The mission involves multiple spacecraft, advanced robotics, and precise coordination, making it one of the most ambitious scientific efforts ever attempted. By fully funding this mission, we protect years of work and billions of dollars already invested, while also enabling scientists to study Martian material using advanced laboratory technology that can't be sent to another planet. Now imagine two possible futures. In the first future, the mission succeeds, the samples are returned safely to Earth, and scientists analyze them using the most advanced tools available. For the first time in human history, we discover clear evidence of past microbial life on another planet. The discovery would transform our understanding of biology, evolution, and our place in the universe. In the second future, the mission is delayed or canceled. The samples remain on Mars, and the opportunity to study them is lost for decades. One of the greatest scientific discoveries in history remains just out of reach. This difference between these futures comes down to one decision: whether we choose to invest in this mission or not. This is why federal policymakers must prioritize funding for the Mars Sample Return mission. Investing in this mission is not just about space, it is about advancing science, driving innovation, inspiring future generations, and maintaining leadership in one of the most important frontiers of human discovery. The samples are already waiting. They have been collected, preserved, and left on Mars for us. Now the only question left is, will we bring them home?